So hello guys, welcome to my channel. So let's go to the questions. So let's see what is the question. So today question is kth smallest element in BST tree. So the title of this question is kth and smallest element of in BST. So this is medium level problem. So let's go to the question. So this is the question. Given a BST and an integer k, they give us a BST tree and a value of k. Okay, find the kth smallest element in the BST using big O of one extra space. So we simply find the kth smallest element from the BST, but we will not use extra space. Okay, so like other, yes, we can just as we say that uh, array list, like other data structure, this type of data structure. Okay, I hope you understand. So what is the question said? I hope you understand. So let's go to the example one. So this is the binary search tree 2 1 3. So I tell you what is a binary search tree. So in binary search tree, there is a root node, and the left child of that root node is always smaller than from root. After that, and its right is always greater than to root node. Okay, so this is the binary search tree. After that, we have a value k is equal to 2. So it means we have to second smallest element find. Okay, so what is the second smallest element? So this is the very first smallest element. After that, this is 2. This is the second element, smallest element. Okay, if we have one here, and there is a 3, there is a 4, so second smallest element is 3. Okay, if there is a any BST. So okay, so second is the second smallest element in BST. This is explanations. And after that, if over k is 5, it means fifth smaller element. So there is only k, there is only 3 element, but so we don't have any fifth element, so simply return -1. Okay, simply return -1. So we have expected time complexity big O of n, and expected space complexity is big O of 1. So this space complexity is very big role in this question. So we have to think in according to space complexity and solve this question. Okay, so let's go to the notepad and understand what is question said. Okay, as question said, given a BST and an integer k, so find the kth element in the BST using extra space. Okay, extra space, big of and extra space. So I hope you understand the question, and let's go to the approaches. Okay, there's a two approaches. Okay, there's a two approaches. You can solve this using two approaches. First one is so we have to use some data structure like array list and other. Okay, array like other array list. So in this case, we are using array list. Okay, so that's why it's space complexity of n, big O of n. Okay, and after that, we simply use another algorithm. It's called Morris traversal. We will see this traversal. Okay, after we will complete first approach. So but the in this case the space complexity is big O of n, and in this case we go with the space complexity is big O of 1. Okay, so this is the biggest difference. So that's why we will see question. So as the if there is a not in any issue in space complexity, so this is the simple method. So we don't need any think about logic. So this is a simple logic, and but there is a special role of this big of one extra space. Okay, that's why we are using Morris traversal. Okay, so let's go to the logic part. First approach. Okay, so what is the first approach set? Okay, first approach said that first step is if you think that, if you see that this tree, this is a binary search tree, it means it is a I hope you I hope you know the binary search tree. I assume that you have better understanding in binary search tree, so that's why if you are not any understanding in binary search trees, so firstly go to the in this topic, so and understand the basic concept. So after that you can tackle this question very well. Okay, so first BST is basically sorted in order traversal. In order traversal, there is a sorting, there is a sorted tree. Okay, sorted element we will got if we saw in if we traverse this binary search tree in order way. So simply we have this, the output is simply in ascending order. Okay, so it means in order. I hope you better understanding in order traversal. So if you are not if you are not very well in order traversal, so first go to my playlist, and after that go see this question. Okay, in order means firstly print left part, after print root, after that right. So go this part, go to left, after that go part to left, and simply print 5, and after that print 7, after that print 8. Okay, if there is a left, so after that if there is a left, so print is the left part, after that is 8, but there is no left, so 8, after that 9, after that 10, after that 12. So this is the way of in order traversal. I hope you understand the in order traversal. So that's why we got, if we got this in order traversal. So what is our first step? First step is in order traversal. Okay, and in order traversal. Okay, and store node into array list. Okay, this is the first step. Okay, what is the second step? Second step is that second step is that second step is that print array list dot cat k minus 1. Simple. This in our array list we have as a sorted order in our this tree. So this is the order 5, 7, 8, 9, 10, 12. So this is a sorted order. So has the this array stored this sorted order. So the kth element is in simple order. So Simply if we want to kth element, so simply kth array list dot get 2 means k minus 2, 2 minus 1, 1 is the this element, 3 is the 4, index of this is 3, is index of this 4, 5, 6. So this is the index of this nodes when it goes to array list. Okay, let's go to the code and run, and let's do the code first. So this is the code. Simply create a function help and pass root. Okay, after that, what is the conditions for this is the in order. Okay, simply we write over here name of this is in order. So root is equal to null, simply return. Okay, if so, after that go to the left part, means in order, root dot left. Okay, then print the root element, add array list dot add root dot data. After that go to the left side, in order dot root dot right. So we have to pass array list. So in this argument we have also pass array, and here also passed array list. Init and teacher value stored. Yeah, this is the in order traversal in BST. Okay, I hope you understand this in order traversal. If you are not well understanding the in order, so you can go to my previous video, so you can see the. Okay, so simply create array list, integer type. Okay, array list is equal to new array list. This is the array list. So after, we have to maintain one case here. If so this is the case in order. So after that we have to one case that if k value is greater than this size of node, so simply return -1. So we will store all the node into the array list. So after that we will check this condition. Okay, I hope you understand this question. So after that, call in order function, in order and pass root. After that, array list. After that, simply check if k greater than array list dot size. simply return -1. Okay, this is the condition. After that, else. So after that, if this condition not satisfied, so simply array list s dot get k -1. Okay, this is the element we want, so that's why we have to push that index. So let's check again if there is condition. So yeah, after that, so let's go to compile the code. Yeah, there is a some syntax error. So in here there is a comma here. And the syntax error is dot left dot. Yeah, I made one mistake. Yeah, comma. Yeah, but it is right, but I think it is right. Array list add list 22 minute. This is the root, this is the left list. So what is the, oh sorry, semicolon, I missed semicolon. Okay, so let's compile this code again. Oh, I hope there is a k symbol. So k's value is, here is, we make small k, so simply, yeah, this is the output. If we put k is equal to 5, so then compile, then this case is handled. If k is the size, so simply return -1. So this code is executed properly. So let's submit this code. Yeah, this code is executed perfectly. So there is no issue in execution or time complexity, but we are using some extra space like array list. Okay, and array list we are using here, and also we are using this traversal. Okay, and this traversal stack, when we are recursively traverse any tree, so we are using recursive stack. So this is also space in the our code. So this type of space we are using. So let's go to the second approach. Okay, so let's delete this approach. Yeah, and move here to this is my approach. Who did this? I hope you understand problem statements, so that's why I did it. So next approach is Morris traversal. Okay, there's a when interview lot of interviewer said ask you some question like, if you traverse this without using extra space, so how you traverse, like this type of question. So that at that time this Morris traversal comes into picture. So this is importance of this Morris traversal algorithm. So it is also form of a threaded binary tree. So it simply means we have used thread in this Morris in this traversal, so that's why. And the time complexity of this is big of n and above big of n, but almost no, but not n square. Okay, above then big of n but not n square. Okay. So firstly we will see this approach through tree. After that we will go to this part steps. Okay, so this is our tree. I hope this is visible to you. Okay, this is 10 7 5 8 9. So we are here. Okay, oh, we are here currently. We are here over current here. Okay, currently we are here starting node. Okay, check if there is a left node or not. Check if there is a left node or not. Okay, let's say there is a 10, so that's why 10 15 20. If this case is let's suppose this case. So if there is a not if there is a not any left node, simply, so we have to simply go to the right node. Okay, so this, if there is a not left node, simply go to the right node. Okay, this is the some case. So if there is a not left node, simply goes to the right node. But if there is a left node, okay, so if there is a left node, so we don't simply go to the leftmost element, this element in left side tree. Firstly we will check, this is the left hand side tree. Okay, left hand side tree. First we will check if there is a right element. Okay, for after that, next step is we don't need to go there left part of this subtree. First we will check, first we will go to the right part. Okay, yeah, after that go to this right part. Okay, rightmost element and reach to the rightmost element. Okay, when we are here. Okay, so what is the next step is, let me create, yeah, this, sorry. So when we are in their rightmost element. Okay, so this rightmost element we have to this is, now we are, our value is this. So let's suppose we don't current, we don't need to move our current. We simply take some element, take some node like previous. We store the value of the current current's left value into the previous, and previous go to this part of previous, go to this part, after this part, and in it there is a previous element node. Okay, so after that previous we have to check if previous, okay, if previous is if previous right is equal to null, previous right is equal to null, so simply we have to create a thread. So thread create that point to this current, sorry guys, test thread. So this is a thread that simply point to this 10 node. Okay, after that go, this is the current. Okay, then current goes to the this, then current goes to the this part. First let's check, first step we have checking the if there is a left part or not. So yes, this is left part. So go to the right part of this rightmost element in left hand side tree. Okay, right hand step we are going. If the right hand is, if the right this element previous element have right it's right if point to null, so simply it to change into point to the current, the previous right point to the current, it means it made a threads from here to here. After that current point to left side. Okay, again the it check if there is a left or not. So yes, it is left. So after that it goes to right part of the element, but there is a no right, so it is also this is the right after that check previous, this is the previous, we made this previous. Okay, check after that we in the above cases this is the previous, so in this condition we are checking previous dot right is equal to null. So if this is going to be satisfied, so simply point to this current element. So this is now current is here, so if there is previous is right is null, so simply point to this. So we simply create a thread from this after the after this and like that. This is I hope you understand the basic idea about thread binary tree, binary search tree. Like that we have to create threads like this kind of threads. Okay, I hope you understand this basic that I taught you in some minute in just now. So after creating this thread, okay, when our current here, okay, when our current here, so as I said that current left is there is a no left part of current. Okay, there is a no left part of current, so simply we store or print like that of whatever you want to, like if I want to store 5, let's suppose I want to store I am storing, I explain you how we not storing this 5 or not. So in this at that time I am just storing 5 here and go to the 5's right part. So 5 right part generally point to the 7, so that's why it our current value is, so our current value is now here again here. So after here remove this threads. Okay, so how our current is here. So after that has current left point to null or not. So it is not point to null, so it is go to this left, this right part of this element, so goes to right. After that is the element we are now here over like previous element. We are checking another condition. Okay, if previous dot right, okay, this right that is point to, if previous dot right is equal to not is equal to null, so simply that I handle above condition, if it is equal to not null, so simply we have to if it is not null, so simply print this current. Okay, print this current. Okay, and point to the current to this, it's right. Now current point is this part. Okay, after that is a node element, so that is why 8 is print here and point to the this part. After that there is a node left part, so print 9 and go to the it's right. Okay, its right is 10. I hope how you are able to understand how we are towards this. Okay, so let's go to the firstly we will erase this all stuff, then we will write in all the cases, so and you will have better understand what is the question said. So what is the approach? Okay, we simply create threads, so we don't need to store node in some data structure like array list. So simply create threads and simply call to left and right of this thread of current node of that node. So this is the approach. Means approach simply said that we use thread here to remove the space complexity. Okay, this is the basic idea of approach. So first question is we have, if we will create thread. Okay, if we want to create threads, so it means we want to create thread from here to here, from here to here. So we have to perform some step. So before moving to the left side, it is okay. Before moving to the left side, it means before moving left side. Okay, it means current. Now we are here. Okay, would over current check first, check left side. Okay, check if there is a left side or not before going to current going to this part. Okay, check this, there is present or not. If there is a present, not directly go to this part, so simply go to the rightmost element node. Okay, go to the rightmost element. So there is an element store here, node, there is a node store here, and this node is go to this element. After that, go to this element, sorry, make its right pointer go to in the left side. Okay, it's light up subtree. Okay, the rightmost element, this is the rightmost element of this left subtree. Okay, and after make this right pointer to the current. Now over current here, and this right pointer is point to null. So if it point to null, so simply create a thread and is right to point to this current. So this simply created, we are successfully created a thread here. So this is the threaded. So this is the answer of this question. After that, if thread is already created, so let's suppose this is created, we are created this step, because when we create this step, thread, so simply overcurrent goes to the this thread, and it performs same for this. Okay, and simply goes to the this current. Okay, so after going this overcurrent here, check if there is a left part or not. So there is a not left part, so simply we have to go to right part. So first we print yeah, we go to the right part. If there is already thread created, means there is a thread. Okay, if there is a created thread, so simply move right and delete, go to the overcurrent, go to there here and delete this. Also print 5. We can also print, we are also print 5 here. So this is a step. I hope you understand this this to answer this question, answer of this question. Let's go to the code. This is the function of this code. In it we are passing current and case value that are we passing. So this is while condition, whenever while current not is equal to null. So current when current is not equal to, so after that it go will this while condition and check. So let me clean all the stuff from the screen. So if current dot left is equal to null, so as I said that this is 10. Sorry. Let's take this example. Okay, if overcurrent is here, let's suppose overcurrent, whenever overcurrent is here, So if its left is equal to not to null, so is equal to null, so it's always then when current is point to this 5, so its left is definitely point to null. So check for nth element, if true then print, and it means check for nth element. So this is the part where I want to print, as I know that this is pre-order, the first left, right, left, mid, then right. So there is a node left. After that there is a turn of this 5 node. So this is a print. So if over where k value is 3, it means this is the first element that we corrected. This is the first element that I remove. So k value is 2, and we remove the k, one decrease the k value. This is the first element. Okay, this is the second smallest element. So when we reach here, so simply delete this, simply reach, so say, and remove k value here now again. So simply 1. So after that we whenever we go here, so check if k's value is 1, it means when I remove this element, this is a third, 2 already happened. Okay, 2 already happened. After that this third, this is the third element. So simply print. So it means 8 is answer. Okay, I hope you understand. Yeah. So that's why I check for the kth element. If k is equal to 1, simply true, then print that element. We will see in the code, and go to the right side. Simple. It's when we are current here, and there is a thread we are creating. Before coming to left side, we are already creating a thread. So that's why its right point to the 7. So overcurrent comes to into the 7. Simply. Okay, so if there, so this is the condition, if there is left is equal to not null, so this will happen. But if there is, okay, now we will go to first step. Okay, if this condition is not satisfied, if means current dot left is equal to some point, there is some point, so let's suppose there is 7. Okay, so else condition we have happened here, so we have to take a node previous, okay, previous, and store this value, this 7 value, current dot left, current point here. Okay, current point here, but after that point or previous point here, and our previous go to the right side. Over previous, if over previous have any right element, we are using while condition. Okay, if over previous have any right element, okay, this condition is satisfied. Yes, there is a right element, and this condition very important condition. Okay, this condition decides the thread is creator or not. So previous, it means previous dot right is equal to is not equal to current. Previous dot right is not equal to current. Current is 10, so it is not current. So simply previous go to this here. After that simply previous go to the next is next. Okay, so after again previously has a light element. Yeah, this is a right element, so it is not proper equal to 10. So simply go to this 8 into the p. Okay, after that this 8 is now after that is check, there is a light element, there is a light element of this not, yes, there is not, this condition is false, so this break this while loop. After that check if previous dot right is equal to null. Yes, previous here, now previous is pointing to here. Okay, so if previous dot right is equal to null, so simply create a thread and go to left side. Okay, so this thread is that are using this thread. This thread is created by this condition. Okay, previous dot right is equal to null means previous is equal to null. So simply create a thread and go to the right side, go to the left side. So after that current go to the left side. Now current point to this. Okay. So here is again current check for left part and again create a thread here. Okay, after that it's not, its left is not, its left is null, so this first condition is checking. Okay, this first condition check, and current is going to here. After that current is going to here. After that current is going to here. Okay, so after that when current is here, okay, let's suppose current is here whenever we are coming back to the root. Okay, so current dot left some element, there is a 5 element, so simply goes to the else part. Okay, this else part, and check if previous means it's left, this is 5, previous dot right, it's good to not right. Okay, and previous dot right is equal to current. This is happened when our current is here.